So we'll solve these problems now. Okay. So once again, good morning, students. Today we are going to start with our numerical integrations. Previous lecture we have discussed about all the rules, and we have also discussed about the Newton's code quadrature formula. Derivations we are not interested, only the formulas are important, and understanding the graph. So we have already discussed about the graph taking x-axis, y-axis. So we'll take some curve y is equal to f of x, right friends? So you can see we are going to calculate the area under the curve, right? So I cannot take directly the area because in geometry we have fixed shapes, that is like your rectangle is there, triangle is there, circle is there, and square is there. So these shapes only we can simplify the problems. But now by using this numerical integration, all the engineers and mechanical engineers, especially civil engineer also, it is quite helpful to find the area, or you want to set up any industry, for that area is required. So here we take the strips one by one and we calculate the approximate values, friends. So next example we are going to take, that is first example, evaluate integration 0 to 1 x upon 1 plus x dx by Wedd's rule, taking 7 ordinates, and hence find log 2. So we will simplify this example, students. So please note down. By using this method, we also find the distances also. I will solve that in the next example. Okay. Yes, students, first write down the given data. So here they have given x upon 1 plus x. So write down first x and y. Can anybody tell me what is the interval you are going to take? That is very, very important. Yes. So first I will take, let f of x, or we also take this as y, is equal to x upon 1 plus, actually this must be square. How I have taken here directly here. Okay, and make it slight change here, friends. Take this as x square is there. Okay, here we go. Fine. So we'll take y is equal to x upon 1 plus x square, and we calculate the answer using Wedd's rule. So you can see they have given here y is equal to x upon 1 plus x square, and they have given here, friends, see, this is 7 ordinates, means what is given here? Given is 7 ordinates. So you can just check the interval here. What is the interval they have given? From this 0 and 1, upper limit and lower limit. From 0 and 1 they have given. So 7 ordinates you are going to find, right? 7 ordinates means what? Ordinates are nothing but x-axis, x0, x1, x2, x3, x4, x5, and x6. So you can see this is 7 ordinates, 1, 2, 3, 4, 5, 6, 7, including x naught, initial value x naught. They are 6 parts. So here we have the 7 ordinates. I have to divide this interval, right? So I will take the here length of each part. Okay, students. So you can just see length of each part, which is equal to, please remember the formula, that is step length, or we also take this as the interval, right, students? So it is b minus a upon n. That is, okay, I will tell you what is a and b. Yes, please remember, this is a. Okay, this is a is 0, b is 1. So I will write here 1 minus 0 divided by. Can anybody tell me what is n? Yes, students, please think.
6.
What is n here?
6.
Yes, very good. N is nothing but 6. So you can see n is nothing but our, how many strips we are going to take, n number of strips. So we can just take this 6 parts that we have taken, n is equal to 6. So therefore this is equal to 1 upon 6. Is it clear now? Okay. So now you will simplify this one by one. Okay, so we'll take first x value. X is equal to, so I will take x and y here. X I will substitute 0. Please tell me what is y value. Substitute in this 0. 0 divided by anything is 0 only.
0.
So I will take 0. Yes, beta, you are right. Next, go for next interval must be again 1.6. So this is going to increase 1 upon 6. Substitute in this equation. Please tell me what is the answer.
0.1621.
Yes, very good. It is 0.1621 beta. Okay. Next, continue this 1 by 6. Then again plus 1 by 6 will become 2 by 6, or we just take this as 1 by 3. Substitute in this formula, students. What you will get, just see.
0.3.
Yes, it is 0.3. I think everyone have got to know how you are going to simplify this. I will tell simple steps in calculator. You can note down. First, you take division, then you take alpha x divided by 1 plus alpha x square you do. Okay, so it will look like this. So I will write it here. First you take division in the calculator, then you can take alpha. This is in 991 ES calculator. Okay, students, so alpha plus x you take, so you will get here x, then division you can continue like this, again alpha plus x, then square, so 1 plus x square you will get here. So then you can put calc button, that is calculate. So when you put calc button, yes, below shift you have it, then it is going to ask you x value, then you can just go on substituting this value. So this is 1 divided by 3 is there, you will get 0.3. Then again press equal to, it will ask again x value, then substitute again. This is going to become now what, this is now we will increase again 1 plus 1 by 6 you will add here. So this will be how much, 1 by 2. So 1 divided by 2 you will get here
0.4.
0.4 you will get. Next, again, you will add 1 plus 1 by 6. So every time you are adding this interval, students, okay? 1 by 2 will become here 2 by 3. So you will take again 2 divided by 3. So you will get here 0.4.
0.4615.
Yes, beta, you are right. So next again 2 divided by 3 plus 1 by 6. Why I am taking 6? This is h and this is x naught. So already you know you are going to add this in your next values. So this value will be 5 by 6. Okay. So please tell me what is the value? 5 divided by 6.
0.4918.
Yes, 0.4918. Yes, students, please do this work. So again, next 5 divided by 6 plus 1 by 6. So you can see this is 6 by 6 will become 1. Yes, you should get here now 0.5. Is it clear till here?
Excuse me, sir.
Yes, beta, please tell me.
So why you took that 1/6 instead of 1 0 1 2 3?
Yes, very good, beta. Good question you have asked. Once again, see here. Everyone, please look at the screen. See, they have given the interval 0 to 1. This is our interval. Okay, fine. So already you know this formula, that is for the interval in the previous lecture, or I've given this formula h is equal to b minus a upon n. Please remember this formula. So this is formula you have to remember every time. So you can see b minus a. B and a are nothing but the lower limit and upper limit of this integration, right? So I will just take here 1 minus a, 1 minus 0. A is nothing but 0, 1 minus 0. And n is equal to, I have taken this as the 6. Tell me why I have taken this 6? Because they have told you 7 ordinates. 7 ordinates means how many are there here? X0, x1. So you can just see this xn. So you can see n is nothing but here 6 parts. So therefore, I have taken here 6. So 1 minus 0 upon 6 is equal to 1 upon 6. Till here, everyone understood?
Yes, sir.
Okay. So you can, so please remember, I have told you the interval are distributed how? This is x naught, then x naught plus h and dot 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 dot. This interval will increase in this form. So first is 0 is there, okay? Because the lower limit here, x naught will be 0, and then xn must be 1. So this is going to become our xn, or you can just see this is 6. So x6 you will get here. So what I have done, I have added this interval every time. So 0 plus 1 upon 6, I have got here 1 upon 6. Yes. So again 1 upon 6 plus again I will add interval 1 upon 6. You can see this is going to be 2 upon 6 or 1 upon 3. So I have written here 1 upon 3. Similarly, again I will add 1 upon 6 every interval, student. Is it clear?
Okay, sir. Thank you. I got it.
Yes. So please remember this, very, very important. Then only you can go to the next step. So this is the first step. What is the given data should be written in table. Okay, x and y. So after finding x and y, then we will use the Weddles rule. So I think you remember the formula. I will rewrite that formula. Weddles rule formula I will write down here. I have. Okay, so just take this formula and write down. Is that example? Okay, so from Weddles rule, we have this formula, but please remember this is for x6. So you can just take note this y0, y1, y2, y3, y4, y5, and this is y6. So you should not write this full formula in the exam also. Please remember, you are going to take only till 6. Okay, so I will take like y naught plus, or in exam, please see here students, don't take full till only till 6. Yes, this is your formula for this example. Okay, so now you please substitute the value. So therefore this is equal to 3 upon 10, right? H is 1 upon 6, so I'll just write here 1 upon 6 as H, into y naught is 0 plus 5 bracket y1 0.1621 plus y2 is 0.3 plus 6 y3 is 0.4, just substituting the values. So all the values are here in this table. Okay, so this is 0.4615 plus 5 y5 is 0.4918. Okay, plus 2 y6 is 0.5 students. So like this you should substitute all the values and tell me what is the answer now. Yes, you can put
0.3715.
it in. Yes, very good. It is 0.3437.
3715, sir.
Okay, it's gone. 3715. So everyone got the same answer? Please check. You should get this answer, students. Okay. Then what you are going to do? Yes. And hence find log 2, students. You can see they have given find log 2. So how you will find log 2? I will tell you. So to find log 2, what I will do? Yes. To find this log 2, I will write here. To find log 2, I will take the integration. So what we have the integration here? Integration x divided by 1 plus x square dx I will take here. Okay, is it clear? So I know only this part. So what I will do? I will go for direct integration. Okay, so this is equal to integration. How you will do this, students? Please remember. I think you remember this formula. Integration f of x divided by f dash of x dx is equal to log of f of x. Log of this f dash of x plus some constant will be there. If it is definite integral, you will not get here 0. Okay, use this property. So please note down this property. So many of them will be not knowing the integration property. So you can write down in your formula list integration. Okay, so here I will take f of x f of x is equal to x. Oh, f of x is this. Okay, I've just interchanged this. F dash of x divided by f of x is equal to log of x. So f of x is 1 plus x square is there. So f dash of x will become, differentiate this 1 plus x square. This is 0 plus 2x. So f dash of x must be 2x, right? So here we have only x term. So I will just multiply here x and divide by 2. So 1 upon 2 integration 0 to 1 2x divided by 1 plus x square dx. So I will repeat once again. See here, students, what I have done here. I will tell you in this left hand side. So I know the integration property, that is f dash of x divided by f of x will give you log of f of x. Is it clear? Now I will take f of x here first. I will compare this equation and this equation. I will take f of x as 1 plus x square. I find f dash of x. F dash of x is nothing but differentiation of f of x with respect to x. Okay. So differentiate. Differentiation of 1 is 0 plus differentiation of x square is 2x. So this is going to be 2x. So if you just compare here, this is only x is there and this is 1 plus x square is there. So here what is missing? 2 is missing. So what I will do, I will multiply by 2 and I will divide this by 2. So therefore this will be in the form of f dash of x divided by f of x. So please tell me what will be this equal to?
Log of 1 plus x square.
Yes, very good beta. Keep 1 upon 2 constant outside. This is going to be log of 1 plus x square in the interval 0 to 1. Is it clear? So now I will simplify this. So this is equal to 1 upon 2 as it is. I will substitute here x is equal to 1. So this is going to become log of 1 plus 1 minus, here I will substitute now x is equal to 0. So this is log of 1 plus 0. Okay. Further you can simplify. You can just see this is going to be 1 upon 2 log of 2. So please remember log of 1 I will get here. Log of 1 is
0.
0. So this is 0. I will leave that 0 term. Is it clear? Okay. So what I have calculated here, I. This is I. I is nothing but, we have taken I is nothing but, I will write here I is nothing but 0 to 1 x upon 1 plus x square dx. So therefore I will take this term here. Okay, I'll just substitute here this value, that is I value I will substitute here, students. So this is going to be 0.3715. So I want to calculate log 2. So therefore log 2 is equal to, I will bring this to this side. So this is 2 into 0.3715. So please tell me what is the answer. 2 into 0.3715 is equal to
0.743.
743 is the correct answer. So please check log 2 is equal to how much. But please see here, this is again to the base e. So please take this as ln 2. In calculator, you can put ln 2. Means this is nothing but log to the base e of 2 is equal to how much?
0.6931.
Yes, it is 0.6931, students. So it is nearly same. It is 0. It is going to be, if you round this, 0.7 you will get. Is it clear? So like this we can just compare this values. So here we have log 2 to the base e is equal to 0.743, students. Is it clear? So like this you should be able to compare the answer also. Yes, any doubt in this example, students? Okay, so we'll move to the next example. Yes, find the distance traveled by a train between 8:20 a.m. to 9 a.m. from the following data. Okay, students, please simplify this. Okay, So here they have given the some data they have given here already. We are going to simplify this problem. Now I can just tell you one simple idea why we have done compared both these values. Means by using this wedge rule, right, we have calculated log 2 as approximate value. Yes, we have estimated the approximate value using wedge rule. Means that this is a simple proof that we are exactly nearer to the answer. Same way, when we take any other example like distance traveled by a train is there, right? Many other examples you will get in this numerical integration. We can calculate the value which is exactly approximate value of the real answer. So here we have the actual problem, right? So now you can see the given data is written here, students. So please solve. Tell me anyone that which rule you will use to simplify this so that you get the approximate answer. That is very, very important. See, whenever they don't give any rules, right? That is trapezoidal rule is there, Simpson's 1/3 rule is there, Simpson's 3/8 rule is there, and Wedd's rule is there. Any rule they don't mention in the question, then please see that you prefer Simpson's 1/3 rule is there. Yes, we normally prefer with Simpson's 1/3 rule, or we can also refer Wedd's rule. So which is we get the approximate answer. So in this case, we will take Simpson's 1/3 rule and we will simplify, students. Okay. So we'll take the solution. Yes. I want to find the distance traveled by a train between 8:20 to 9 a.m. So they have given here some data. From the following data, they have given the time and the speed in the miles per hour they have given here, students. So I'm going to find the distance now. See, by knowing the time and by knowing the speed, using Simpson's 1/3 rule, you can calculate the distance traveled by a train. This is a very beautiful example we have here, students. You can just write down now. Okay. So I will start with first here. So we know that the speed is given, or the distance we are going to take. Let yes, I will take yes is nothing but speed, or we can just take this as the distance traveled by a train, which is equal to, okay, so I will take the integration sign, students. Why I take integration? Any idea? Anyone? Please tell me why I should take integration sign here.
Because we have to find the distance. Distance is the area under the curve.
Right. This is one thing is that I have told you. I want to find the distance, so I am taking integration. But what exactly integration does, I will tell you this closely. Integration just take the sum of all the values, right? When we take sum of all the values, we will get the total value, which will be nothing by helpful of the integration. It is possible, friends. Okay. So now I know the 2 times are required. That is, I will take the T1 and here T2. Okay. So I am going to find here first. I'll say this as let S be the distance traveled, right? Okay. Then to find this distance, when I take the sum of all these values, that time with respect to speed. So can anybody tell me what is time with respect to speed? What we have to calculate here? Any idea? I think this is a distance divided by time taken, right? Anyone? Rate of change
Velocity,
of
sir.
very good, beta. That is velocity. Okay. So here we take velocity. So like this, you have to think in the exam. And this is dt. Why I have taken dt? dt is nothing but the change in the time. So here we take this. S is equal to integration T1 to T2 V dt, student. So please remember, it's a very good application we have. So next, what I require here? I want to find, next step, I want to find the interval, because without interval it is not possible, students. So I take interval h. Can anyone find what is the h value? Please, will you do it? Okay, I will give one clue. See, in this interval, either you can take in this form, or I will show you one simple clue. This is x0, x1, x2, x3, and this is x4 is there. So I want here b minus a upon n. Am I right? So can anybody tell me what will be n is equal to?
5. 4.
Yes, it is 4 is the correct answer, because here xn is there. Please remember the last term we always take xn value, therefore n is equal to 4. Now tell me, suppose the initial value, integration of this initial will be time, we will take from 0. So I will start from 0. Okay, initially, because initially they have given 8.2 am, but please remember, when we start from 8.2, the initial value we will consider here time as 0. So every time, what is increasing here? How much time is increasing? Yes, any idea? 8.2 to 8.3, 8.3 to 8.4.
10 minutes, sir.
Yes, so 10 minutes. So in this 10 minutes, but we are calculating this in terms of hours. So if you calculate 10 minutes in terms of hours, how much you will get? Just see,
0.1.
60.
1 by 6, sir.
It is 1 divided by 6 hours. So please just see, this is 10 minutes. In from 60 minutes, we have taken 10 minutes. So this will be in minutes, like, so we're converting this into hours. So it is 1 upon 6 hours. Right. So therefore, you can take this interval as 1 upon 6, because in this time, T1 and T2, here they have not given here fixed. So therefore, you can see the interval directly, it is 1 upon 6 hours. But please remember here n is equal to 4 is also there. Okay, so we will take this as directly h is equal to 1 upon 6, students. So like this, you should calculate the interval. Okay,
So then what
now
about that formula,
we will
sir?
use, formula is not helpful, because here only we can easily calculate. 10 minutes gap is there in between. And they have not given this formula is helpful when they have given the upper limit and lower limit. That is, if they have given this interval, then you can take A and B, but they have not given, so I cannot use this. Yes, you are right, beta. I cannot use this. It is not required. So directly you will get h is equal to 1 upon 6. Is it clear? Okay,
Yes,
so
sir.
we will go with the, thank you for your reply. We will go with the now Simpson's 1/3 rule. So please remember now, this value are not y0, y1, y2, y3, because they are speeds in miles per hour. Therefore, I will take this as velocity v0, v1, v2, v3, and v4, students. Now you take Simpson's 1/3 rule. So I will take this as now S is equal to, S is nothing but the integral. Already I told you I want to calculate S is equal to integral T1 to T2 V of dt. So I will take S. S is equal to, this is H upon 3 is there. Then first and last value is V0 plus last value is V4. Add them plus 4 times. I will get here odd terms. Odd are, how many odd are there? V1 is there and V3 is there. So odd, please remember this, odd 4 into odd terms plus 2 into even terms. So even V2 is there, but see here V4 also I should write here, but already I have written here V4. So I cannot write V4 again and again. So I will close with V2 only. So here is the formula you have to remember how you are going to substitute. Now you can just substitute the values. So this is equal to H is 10 minutes. 10 minutes we have converted in this hours because this is speed in hours and they have given this timing in minutes. So therefore I will substitute here 1 upon 6 divided by 3, right? Substitute the values. V0, here we have 24.2 plus V4 is 39.4 plus 4 times V1 is 35 plus V3 is 42.8 and plus this is 2 times V2. V2 is 41.3. Okay, students, substitute and tell me the answer.
$25.411.
Yes, but the answer is right. Yes is equal to 24.111. This is our distance.
Sir, 25.411.
Okay. Sorry, but I had not heard you. This is 25 point. I will write once again. Yes is equal to 25.411 distance traveled by train. So this value is exactly approximate value of distance traveled. So like this you can also get the problem of area also. Sometimes you can also calculate the area, you can also calculate the distance, right? Isn't clear? Any doubt in this problem? Yes, students? Okay.
Sir, is that 25.411 miles, sir?
Yes, distance means this is miles. So this much distance it has covered. So now calculate the next example, students. Example number 3, evaluate integral 0 to 6 dx upon 1 plus x square by using trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule, Wedd's rule. Compare the result with its actual value. So this will be proof that the answer what we calculate in trapezoidal, Simpson's 1/3, then Simpson's 3/8 and Wedd's rule, it is approximate value with the actual value. Yes, students, please tell me the answers now. Yes, do it fast. I will give some hint. Wait. Again, you will get confused. So here we have first, I will take the value that is I is equal to integral 0 to 6 dx upon 1 plus x square. Okay, 1 plus x square I will take here, students. So here I will take y is equal to 1 upon 1 plus x square first. Is it clear?
This was
Here you
done,
can
right?
see the interval.
This was done, right? This question was done.
This is done, huh?
Yeah.
Yes, sir. The first sum.
But this is in the interval 0 to 1. Nahin, x upon 1 plus x square 0 to 1 this
No,
is.
not
Not
this
this one,
one.
sir. Yesterday.
Yesterday we had did.
Yesterday you have done. Okay, fine. So we will do a next example. We'll go to the next example then. Yes. Okay, so we will take this example. Or have you done this example integration 4 to 5.2 log x dx?
No.
Okay, this is interesting example we will take then. Okay. So here you can see, students, very interesting example. This is also. Yes. So we'll take this as example. Fourth example we'll take. Okay, students. Solve this example and tell me the answers now. This is also actually, this is in terms of E. They will actually mention here. But if they don't mention, please consider this as E only. Okay, now you can see they have not given the table here, right? So how you will simplify this problem, students? First take let the function they have given here, I is equal to integration 4 to 5.2 log x dx. So here is clearly given that y is equal to log x to the base e, this is. Okay. Also you can see they have given the interval. They have given the interval h is equal to 0.2. Suppose they have not given the interval, then how you will do it? Any idea? Yes. Here they have told you to calculate, this is Simpson's 3/8 rule. Here you can just remember there must be Wedd's rule also they have given here. So there must be 6 intervals. So 6 intervals, how you divide? Just a clue, this is 4 to 5.2 they have given the integral, or upper limit and lower limit they have given. That is 4 and 5.2. So how much I have to divide this such a way that this must be at least 6 parts of this. How you will do it? Very simple. 5.2, I will just say 5.2 minus 6, and this value must be divided by 1 divided by 6. 5.2, and this is 4. What is the value? 1.2. 1.2 divided by. Yes, this is again a simple calculation. Just now I have just found out. See, n is equal to must be 6. I will take here. Okay. So as I told you, this is A and B. So h you can also verify like this. Suppose they have not given h. We'll assume that h is not given in the question. Okay, h is nothing but equal to b minus a upon n. So how you will choose n? You have to, it must strike in your mind whenever they have given Weddles rule, right? So there must be 6 divisions, 6 strips must be there. If it is trapezoidal, 1 strip. Simpson's 1/3 rule, 2 strips we take. Simpson's 3/8 rule, 3 strips must be there. Weddles rule, there must be 6 strips at a time, means n must be equal to 6. So I'll just substitute the values. B is nothing but 5.2 minus A is 4 divided by 6. Please tell me what is the answer.
0.2.
0.2.
0.2. This is how they will twist in the exam. Okay, so h is equal to, we will take like this. We have calculated the h value. We'll remove h value in the question. Okay, students, then please solve the next value. You will easily do it. Okay, so it will start from 0.2. So all this you have to remember while solving the problem. Okay, I'm going to divide this interval now 4 to 5.2 in the interval 0.2. So means I will be taking x naught, right? Next term will be x naught plus h. Next term will be x naught plus 2h. I think you remember this interval. Then you will get xn. Fine. So I will take now x value here. X value will start from 4. This is the first interval they have given. So I will take here 4 value. I will take here 4. Fine. The next value, please tell me what will be the next value.
4.2.
Yes, absolutely right, beta. It is 4.2. Next value 4.4, 4.6 plus 4.8, and you will reach to 5, and this is 5.2. I will just return here plus, wrong it is. We are just adding this value. So here we get the all x values. Then corresponding y values I want to calculate here, students. So y is what? Log of e, right? So in calculator, please do what I say you. That is, you can just take ln of 4. Please tell me what is the answer. Ln of 4.
1.386.
Yes. So right here 1.3863. Continue. Ln 4.2. Yes, it is 1.435 you take, and 808 it is, round figure will become 1. Continue this 4.4. So this will be 1.4816 value. So 4 digits will take for approximate value. Ln of 4.6. So this will be 1.526. Okay, ln of 4.8. So this is 1.5686. I will take 5. You take, students. This is 5. You will get this as 1.6094. Next value, please check. 5.2 ln will become 1.6486, or we'll round off this 7. Okay, so these are the values here, students. Okay, please substitute and tell me one by one answers. Let us see. I will go write all these formulas are required. I think here till here this is all given data. Step 1, you have to write the data properly. Okay, students, so just take all the formulas. I will take here. Where I have written the formulas. Here are the formulas. Use these formulas and tell me all the answers quickly, students. You should be now fast. Here is this table. Yes, here I have. Yes. So substitute the values. Please remember here n is equal to 6 is there. So I will write here I is equal to h upon 2 y0 plus y6, okay, plus 2 times y1, y2, y3, y4, y5. Okay, please tell me the answer here. Is it clear? Next, I will take I is equal to h upon 2. This is y0, y6 plus 4 times. This is odd, so y1 is odd, y3 I will get here odd. I think y5 I will get here odd. Then 2 times even terms. Y2 is even, y4 is even, y6 is even, but y6 I have written here, therefore I will conclude here. And here substitute the values here, students. Please tell me the answers one by one. So all the rules you are going to write.
Sir, for Simpson's on third, it is h by 3, right?
Sorry, h by 3. You are right, beta. This is h by 3. In hurry, have written this 2. Okay, this is 3 is then. Okay, thank you to remind me, beta. So again, now substitute. This is 3h upon 8 is there. y0 plus y6 plus 3 times. This is y1, y2, y3 you will not write. y4 you will write here. Plus y5 and y6 will not come. Okay, and here I have 2 times. This is multiple of 3. Multiple of 3, y3 only I will get because y6 is already written. So only this much. Okay, then wedge rule I will come here. This is I is equal to 3h upon 10 y0 plus 5y1 till y6. It means I will be writing till here only. Okay, students, please do this. Okay, remaining part I will leave you to do all these calculations. Then what I do here, here this is important. Compare it with exact value. So for that again, you are going to compare with the exact value, means I will take this value. Yes. And I will simplify here. Yes, exact value means, students, I will just try to simplify this answer. So this is equal to, you can see, log, this is again to the base e is there, means I will be taking ln, or simple logarithm you can just see. I cannot integrate log, therefore I will take into 1 for my simplification, and I will do u into v. So you can just see integration of u into v, students. So I think this is u is there, integration of v minus integration of integration v and differentiation of u. Please remember the formula of u into v. So here I will take u log, so I will take here log e to the base x integration of 1 minus integration of integration 1 differentiation of log to the base e. Okay, so use this formula. So this is equal to log x, I will keep it as it is. Integration of x is x only, please remember, minus. Then integration of integration, first I will integrate this inside the integral. This is x into differentiation of log x 1 upon x in the interval 4 to 5.2. This is, so again x will get cancelled. So this is x log x to the base e. This is minus. Your integration 1 will remain, integration of 1 is x. So this is between 4 to 5.2. Simple integration this is, friends. Okay, now substitute the value of x 5.2. I will substitute wherever x is there, 5.2 I will put. So this is 5.2. So this is log e to the base e. This is 5.2 minus 5.2 minus. Now I will substitute x is equal to 4. Wherever x is there, I will just substitute here 4, friends. So log to the base e 4 minus 4. So please tell me what is the value. How you will calculate, I will tell you. Say in the calculator you just take 5.2 into ln of 5.2. Please remember, log to the base is nothing but ln in the calculator. Calculator will be easy, nahi? Minus 5.2. So I will get here some 3.37 30 minus. Okay, same way I will go for 4 into ln 4, right, minus 4. So I find out it is 1.5451. So if you simplify this value, it will be nearer to, yes friends, it is 1.8278 I will get here. So what you have to do now, yes, you can just calculate this value, and the purpose of calculating this is to compare with the nearest value. So I think the nearest value we are going to get from the above equation is nearer, that is Wedd's rule will be slightly nearer to the exact value. Therefore, we take Wedd's rule is nothing but approximate value, students. So here we conclude the class. Yes, friends, thank you. Any doubts is there, you can ask me.
Instead of doing that, we can get directly from the calculator now by substituting ln x.
Definitely. You're quite intelligent. Yes, beta. You can do that work also. But here for simple, yes, you can do that also. Very good. You can also directly take the integration and substitute the value. You can put ln of x also. Definitely you will get the same answer. Okay. Yes, anything else? Yes, students, any doubt? Okay, so we'll continue in the next class. Okay, students, thank you so much. If you have any doubt, please ask me.